Okay, the next section that we're looking at is 12.6, and our topic here is composite surface area and volume. Okay, so what we're going to be doing here is we're going to be either finding the surface area or the volume, okay, of a composite figure, meaning two figures put together. So like if I looked at this figure right here, I don't have any one formula for this entire figure, but if I notice that it's a pyramid on top of a prism, then I can find the surface area or volume of the pyramid and then add it to the surface area or volume of the prism. Okay? Now, with surface area you have to be careful, because with this figure you can't just find the full surface area of each of these two things and add them together. Here's why. Okay? If I got the full surface area of the prism and the full surface area of the pyramid and added them together, it would be too much. Why? Because when I put them together, these two surfaces are not showing anymore, right? So we have to subtract those off. So again, when I put these together, okay, these inside faces are not a part of the outside surface area of the figure anymore. So we have to make sure that we take that into account. So like I say, you can't just find the surface area of this and add it with the surface area of this, because these two faces are not showing anymore. You got to take them out. How do we do that? Well, let's think about it like this. Let's say I wanted the surface area of the prism. Well, remember, the surface area of a prism is pH plus 2b, right? pH plus 2b. Well, here's the thing. One of the bases is now covered up, right? One of the bases is now covered up. This base, the top base, is now covered up, right? So instead of pH plus 2b, my formula is going to be pH plus b, just 1b. Why 1b instead of 2? Because one of the bases is now covered up and not a part of the surface area. Okay? Now, what I need to do is I need to add that to the surface area of the pyramid. Now, again, it's going to be the adjusted surface area. Now, the surface area of a pyramid is typically 1/2 PL plus B. And by the way, all those formulas are all in the notes, and they're all still open on Canvas. So you can go and pull up any one of those sets of notes that you need to get the formulas you need. But anyway, the surface area of a pyramid is 1/2 PL plus B. Now, here's the deal. I need to adjust this formula too, because the base of the pyramid is no longer showing when I put them together, right? The base of the pyramid is no longer showing, so I need to take that off. So instead of 1/2 PL plus B, it's just going to be 1/2 PL, and then that's it. We don't have to add the B to it. Okay? So this now is the formula that I need to use to find the surface area of this figure. Okay? So the first thing that you want to do is adjust your formulas that you're adding together. Remember, this pertains to the prism. This pertains to the pyramid. So now we can go in and plug in our parts. Well, P is perimeter of the base, right? And remember, this is the base of the prism. 10, 10, 10, 10 makes 40. So that'd be 40. The height of the prism from base to base is 8, plus the area of the base. 10 times 10 is 100. Plus, now we're to the pyramid part of the formula. So P is still perimeter of the base, and the dimensions are the same, 10, 10, 10, 10, all the way around. So that's also a 40. Now, here's where we're going to have to do a little extra work. L stands for the slant height that's not given to me. Okay? But remember, if this is 10, from here to here is 5. They've given me the real height as 6, the real height, the slant height, and when you connect them together, that'll make a right triangle inside of the pyramid. And so the slant height is missing, and so that's the hypotenuse. That's my C. So I'll go 5 squared plus 6 squared equals x squared, and then that will be my slant height. I'm ready to take the square root of both sides here now, and we get x is equal to whatever the square root of this is. Let's see what it is. Let's see, pull up the Desmos, and we'll go square root of 5 squared plus 6 squared, and then that's 7.81. Okay, and that is going to be your slant height, 7.81. So now we can go ahead and see what the value is now, because we've got everything plugged in. Back to the calculator. So we'll go 40 times 8 plus 100. Oops, I missed my 8 there. 40 times 8 plus 100 plus 0.5 times 40 times 7.81. And there is your surface area, 576.2. Okay, so for this type of problem, the main thing is make sure you're adjusting the formulas correctly in order to get the correct surface area. All right. Now I want to find the volume of the same figure. All right. Now, when you put two figures together, the surface area is definitely affected, right? Because some surfaces are not showing anymore. But remember, volume is the inside space of the figure. So the question is, when I put these together, is the volume affected at all? And the answer is no. The volume of this and the volume of this will be the same, regardless if I put them together or pull them apart. So with volume, there's no adjustment to the formula that needs to be made. All right? The only time you have to adjust the formula is when you're doing surface area. When you're doing volume, just find the volume of each one and add them together. So the volume of a prism is capital B times H, plus the volume of the pyramid is 1/3 BH. So you don't have to adjust the formulas like we did with surface area, because none of the bases are the volume's not diminished when you put the figures together, like the surface area is covered up when you put those figures together. So no adjustment made here. What's B stand for? Area of the base. Now remember, this one pertains to the prism. So the base is 10 by 10, so that would make an area of 100. And then the height is still 8, just like it was for the previous problem, plus 1/3 times. Area of the base is still 100. For the pyramid, 10 by 10. But the height, the real height, is what we need now, and we have it. It's 6. Okay? And so that one is a little bit easier to plug in because there's no adjustment to be made, and the calculations are a little bit easier. When you go and plug in, it's very straightforward. So we'll go 100 times 8 plus 1/3 times 100 times 6. And we see that the volume comes out to a nice even number. 1,000 is the volume. All right? And remember, that's cubic units, by the way. Okay, here's another one that we want to figure out here. Okay, so what we've got here is we have a triangular prism, but then there's a cylindrical hole that is drilled out through the middle of the figure, and we want to find the volume of this figure. So let's think about this for a minute. Okay, I have a prism with a hole drilled through the middle of it. Okay, cylindrical hole. Here's the deal. Okay, if I were to find the volume of this whole prism, that would be too much because there's some empty space. The hole in the middle is empty space, right? Okay, so what I need to do is I need to find the volume of the entire prism, right? Find the volume of the entire prism and subtract off the volume of the empty space, or the hole that's drilled through it. Okay, so I'll need to find the volume of the prism minus the volume of the cylindrical hole through the middle of the prism. All right, so that's our task. Formula-wise, we'll start off with BH, because that is the formula for volume of a prism. Now remember, we're subtracting off the volume of the cylindrical hole, right? Well, what's the formula for volume of a cylinder? It's pi r squared h. So that's what we're going to be subtracting off here. So remember, this part of the formula pertains to the prism. This part of the formula pertains to the cylinder. All right, so we have the volume of the prism, and we're going to subtract off the volume of the cylinder. So let's go and fill in. What does B stand for again? B stands for area of the base. What's the shape of the base of the prism? Okay, it is a triangle. How do you find area of a triangle? It's 1/2 the base times the height. And so we'll calculate that as 1/2. The base of the triangle is 10. The height of the triangle is 8. 10 times 8 is 80. Half of that is 40. And so what that means is the area of the base is 40. And then that's the value to go in for the capital B. Now, what's the height of the prism? Remember, height of the prism is from base to base, not necessarily from top to bottom. So from base to base, we have this length, which is 12. That'll go in for the h, minus pi times. Now we're to the part of the formula that pertains to the cylinder, right? So I want to know what the radius of that cylinder is. Well, they've given me a 4-inch diameter there. So if the diameter is 4, we know the radius is 2. 2 goes in for r. And then the height of the cylinder is going to be the same as the height of the prism. It's from base to base. And since there's a cylindrical hole through the figure, we know that the height of that cylinder is going to be 12. Okay? So now we've got everything plugged in like we need to. We'll go to the calculator and let it finish it for us. So we'll go 40 times 12 minus pi times 2 squared times 12. And then so we come up with our volume, 329 point, we'll say 2, and then that's cubic inches, cubic feet, whatever the volume is. It's not specified here, so we'll just call it cubic units. All right? So again, the key is making sure that you adjust your formulas correctly based on whether you're trying to find the surface area of the composite figure or the volume of the composite figure. And remember, if you're putting two together, you'll add them. If there's empty space, then you'll have to subtract that off. All right? So that's it.